Okay, this is lesson 3.4 on velocity and the rates of change. So in the I think in the earlier sections we've talked about that the velocity and slope and derivative are all the same thing. So this is just reminding you that instantaneous rate of change is also the derivative right here. So the formula is the same. Instantaneous velocity is the same. I think so instantaneous rate of change and instantaneous velocity are the same thing. So they have the same exact function here. If you're looking for average rate of change, then it is total distance over total time. So that will give you the average rate of change. And then acceleration is the second derivative. So the first derivative will give you velocity. Second derivative will give you acceleration, right? And then this is some information to remember in terms of gravity for English units and for metric units, okay? All right, so we're on the first part where it connects to physics, right? So it says a particle moves along a line so that its position on any time in t is greater than 1 is given by the function s of t equals t squared minus 3t plus 2, where s is measured in meters and t is measured in seconds. All right, so we're looking for a couple things based on this function here. So first thing says find the displacement during the first 5 seconds. It wants the difference between 0 seconds and 5 seconds. So you cannot just assume your start at 0 when t equals 0, you start at 0. Sometimes you start off at a certain position, at a certain height. So you got to find s of 0 and s of 5. So s of 5 and s of 0. Plug it into the function here. So s of 5 is 25 minus 15 plus 2. It gives me 12. S of 0 is 2. So the displacement is 12 minus 2. That's 10 meters. So that's the difference from beginning to the end of 5 seconds. All right, so it's a change in the position. All right. Next, find the average velocity during the first 5 seconds. So it's the total distance over the total time. Well, the total distance I got from part A, that was total distance of 10 meters over 5 seconds. So it is an average speed of 2 meters per second. Okay, so you need part A to do part B. Be careful of problems like this because there has a rolling effect that if you get the first one wrong, usually the second one is wrong too. So really check your answers, okay? C, find the instantaneous velocity when t equals 4. So you need to find the velocity function v of t by taking a derivative. So that's 2t minus 3. Then you plug in 4 to say, hey, what is the velocity at 4 seconds? It gives me 8 minus 3. The velocity actually is 5 meters per second at 4 seconds there. Okay. Then it says find the acceleration of the particle when t equals 4. So acceleration, you need to take one more derivative. So look at this v of t. A of t will be 2. Oh, that's great. Because there's no variable here, then acceleration is 2 meters per second squared no matter what time you are. So this one, I believe, is a parabola. Okay? All right. Oh, it is a parabola. T squared minus 3t plus 2 is a parabola. So your position function goes something like this. So it goes faster and faster and faster as it goes up. But the acceleration is pretty constant in this case. Okay? All right, next one. At what value of t does the particle change direction? So this is the same picture I was drawing. Your particle was going this way. Sorry, it was going this way and it comes up. So when does it change direction? It changes right there, right? Because it was going down and it goes up. So what happens at that point when it was changing direction? The velocity at that point is actually 0. So that's how we find when this happens. When does it change direction? Oh, it's when velocity is 0 because it paused and then went on. So you simply take the velocity function you got from before and set it equal to 0. So v of t equals 0. 2t minus 3 equals 0. T equals 3 over 2, which is 1.5 seconds. So at 1.5 seconds, it is going to change direction. Okay. Where is the particle when s is a minimum, right? So you know that it changes direction. That is the minimum height. It's the lowest it gets because it goes down and then pauses at the minimum height and it goes up. So where is it? What is its position? Well, you simply take 1.5 and plug it back into the position function. So s of 1.5 is equal to 1.25 minus 4.5 plus 2. And the position is going to be negative 0.25 or negative 1/4, depending on how you interpret this. So here's the thing. How can you have negative 1/4 meters? It doesn't mean negative 1/4 meters. It means that wherever your 0 is, your sea level is, negative 1/4 means it's below wherever you were at, wherever your starting point is at. So positive means it's going up, negative means it's going below where you started. Okay? All right. Please make sure you watch the second video for the rest of this lesson. All right? That's it.